All right, my friends, are you ready for the demo? I remind that this demo works for any dataset, regardless of the number of features, and as long as they have, the features in the first columns and then the dependent variable in the last column, and also assuming that any missing data or categorical data was already taken care of thanks to your data preprocessing toolkit. All right, so this is going to be very exciting because it's really now that I'm going to show you the power of code templates and how you can quickly and efficiently select the best regression model. All right, so let's do this. Enough talking. I'm going to proceed to the demo now, just resetting everything because we're going to do something fun. We will actually use this run all option of the runtime, which will run all our cells at once so that we can really optimize the efficiency. But let's not forget to upload the data set in each of the implementations. Otherwise, this cell won't be able to execute. So we're going to upload it now. It is connecting to runtime, and in a second, we should be able to see the upload button. There we go. So let's click this upload button. And now on your machine, you're going to find the folder, the model selection folder. That's the whole machinery ADZ folder. And that's this new model selection folder containing, that regression folder with all the code templates for regression and the classification with all the code templates for classification. If you missed that folder somehow, don't worry. It was given right before this tutorial, in the article. At the bottom, you had a zip folder attached, which you could download on your machine and which contains exactly the same as what I have here. All right, so now we're going to go to the regression folder, which contains all the implementations, meaning all the code templates for each of your regression models, both in IPYNB format, which you can open with either Google Colab or Jupyter Notebook, and in PY format, which you can open with a classic Python terminal or Spider in Anaconda. So you have everything, and you also have the dataset, containing these 4 features: the ambient temperature, the vacuum, the ambient pressure, and the humidity, and we predict the energy output. All right, so that's a very classic data set, once again, very generic, trying to represent the other future data sets you'll be working on. And well, speaking of this data set, that's exactly what we have to select here. So we're going to click open to upload the data set in our notebook. And there it is. And now, as I told you, here in the implementation, you only have to enter the name of your data set. And as far as we're concerned here for our demo, well, this data set is called data.csv. All right, so now we're going to quickly do exactly the same for our other implementations. Upload, then data.csv, then open and loading it, uploading it, and we'll have it in a second. And then we'll just replace the name of the dataset here by data.csv. So that's for polynomial regression. Now for support vector regression, well, same, upload data.csv, open, and loading it, uploading it. In a second, we should have it. There we go. Now we only replace this by data.csv. Then for decision tree regression, there we go, upload, then data.csv, open, and we will have it in a second, uploaded in the notebook. And now replacing this by data.csv. And finally, for random forest regression, upload, data.csv, open, and now replacing this by data.csv. And now, my friends, we are finally ready to test each of our regression models and figure out in a flashlight which one is the best. Remember, the closer the R-squared coefficient is to 1, the better is your regression model. So in order to figure out which is going to be the best model, we'll just take the one with the highest R-squared, with the R-squared that is the closest to 1. All right? Are you ready? Let's do this. Starting with multiple linear regression. So now we're simply going to go to runtime and then run all. And all the cells are now executing. And there you go. We end up with an R-squared coefficient of 0.93. Very good one. As we can clearly see, the predictions are amazing. They're very close to the real results. So remember, this first column is the vector of predictions, and this second one is the vector of real results. And that's why here we have an amazing R-squared coefficient.